All right, continuing on now. When we're trying to solve for the x here, and the x is in a parenthesis, I've got to get the parenthesis alone. We don't distribute anything. This is 2x plus 2 squared equals a negative 18. Then I got to get this coefficient out of there. I do it by dividing. X plus 2 squared equals a negative 9. When you have a square on a parenthesis, it's the same deal. You take the square root of the parenthesis, and you're left with the parenthesis without the square on it. The square root of negative 9, well, the square root of 9 is 3. So the square root of negative 9 is 3i. And then we need to finish the problem by subtracting 2 to the other side. Get used to the fact that answers are going to look like this. Hence the term complex numbers. The answers will be a complex number. It's not like you have to do anything with it. So you leave the answer as such. Second one, I'm going to add 4 to both sides. 3 times x minus 3 squared equals a negative 30. I divide everything by 3 on both sides. The 3's cancel, and I'm left with x minus 3 squared equals a negative 10. Once again, to get rid of the square, we take the square root of it. And what we do to one side, we do to the other. We're left with x minus 3. Now 10 can't be simplified. So it's simply plus or minus I root 10. You always take the negative out and put an I in front if you have a negative in the radical. You never leave the negative in the radical. And then we simply add the 3 to the other side. And my answer becomes 3 plus or minus I root 10. And there's our answer. Now, I may ask you to simplify radicals that are a little bit more complicated. The fact that they're negative just means there's going to be an I on the outside. So I actually deal with the number without the negative to begin with. If the number's even, you're dividing it by 2. And you keep dividing it by 2 until you can't divide it by 2 anymore. Then you start trying to divide by 3, by 5, by 7, by 11. You're only dividing by prime numbers. But as long as that even number is even, you're dividing it by 2. The second that number becomes odd, then you can try and divide it by 3, 5, 7. This now is broken down into all prime numbers. Anything that pairs goes on the outside. Anything that doesn't pair goes on the inside. If you have multiple pairs, you multiply them. If you have multiple numbers that don't pair up, you multiply them inside the radical. Root 48 is 4 root 3, so negative 48 under the radical is 4i root 3. That's the only difference. 160, I'm going to keep breaking it down. 2 and 80, 2 and 40, 2 and 20, 2 and 10, 2 and 5. Pair of 2s, pair of 2s. If there's multiple pairs, they get multiplied on the outside. We have a 2 left over and a 5 left over. If you have multiple non-paired numbers, they get multiplied on the inside. So root 160 would be 4 root 10. Since it's negative 160, the only difference is it's 4i root 10. That's it. When we add complex numbers, all we're doing is adding the real numbers together and then adding the imaginary numbers together. 6 and negative 3 is 3. 3i and 7i is 10i. That's the answer. When you subtract, I strongly suggest copying over the first complex number and distributing the negative to both terms of the second complex number, making this a positive 6 and this a negative 11i. and then we're going to combine like terms. Negative 5 and 6 is 1. Negative 8i and negative 11i is negative 19i. So we multiply complex numbers, we should get a complex number back. We're simply foiling. 4 times 3 is 12. 4 times negative 8i is negative 32i. 7i times 3 is a positive 21i. And 7i times negative 8i, positive times a negative is negative, and it's negative 56i squared. And the key here is this, to recognize that I squared doesn't get left as I squared. I squared is a negative 1. We need to know I squared equals negative 1. So therefore, negative 56 times negative 1 is a positive 56. And we finish the problem by combining our like terms. 12 and 56, 68. Negative 32 and a positive 21 means we're at negative 11i. And that's our answer. Our second one, 3 times negative 5, negative 15. 3 times 2i is 6i. 4i times a negative 5 is negative 20i. 4i times a 2i is 8i squared. Once again, I can copy the entire thing down. I squared equals negative 1. So this becomes a negative 8. Negative 15 and negative 8 is negative 23. 6i minus 20i is minus 14i. And those are my two answers. When you graph a complex number, the real number acts as your x-coordinate. The imaginary number acts as your y-coordinate. So I would argue this would be like I, and this would be 1. Okay? So 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. 6 plus 8i is out on the graph. And to get your absolute value, you're talking about your distance from 0. So I'm actually going to now take this I out of there. Okay. And we're talking about the distance of this line. Well, how do I get that distance? It's literally a hypotenuse. We went up 1, 2, 3, 4, 5, 6, 7, 8. The length of that line is 8. 1, 2, 3, 4, 5, 6. The length of this line is 6. So how do I get the length of this line? When you find the absolute value of these numbers, it's literally done through a Pythagorean theorem. It's 6 squared plus 8 squared equals c squared. 36 and 64 is 100. So the square root of 100 is 10. The absolute value of 6 plus 8i is 10. Okay? You're literally just taking the square of the integer and the integer in front of I, adding them together, taking the square root of that sum. If I were to graph negative 3 plus 5i, I'm going left, 1, 2, 3, up, 1, 2, 3, 4, 5. This is where negative 3 plus 5i is. To get that absolute value, we're simply doing negative 3 squared plus 5 squared equals c squared. 9 plus 25 is 34, which equals c squared. If you can't take the square root of something, you just leave it under the radical. The absolute value of negative 3 plus 5i is root 34. That's it. Negative 2 minus 7. I'm going left 2, down 1, 2, 3, 4, 5, 6, 7. Negative 2 minus 7i. The absolute value, negative 2 squared plus a negative 7 squared. 4 and 49 is 53. 53 can't be simplified, so it's just the square root of 53 is your absolute value. If you can simplify the radical, you do so. One second. And then finally, 1 minus 3i. We go right 1, down 1, 2, 3. That's 1 minus 3i. The absolute value, we're doing 1 squared plus negative 3 squared equals c squared. That's a sum of 10. And my c is the square root of 10. That's how I get my absolute.